Hello, welcome back. Today we are going to finish up lesson 3.2, solving systems of three equations in three variables. And if you felt like you were more of an elimination person, then you will probably like this method better. Okay, so you will need your Springboard book. We are going to start this on page 38, kind of right where we left off. You'll need a pen or a pencil, a calculator, and again, these problems tend to take up a little bit of space, so you'll also want a sheet of paper nearby or your notebook, okay? So it says here, on page 38, another method of solving a system of three equations in three variables is called Gaussian elimination. Gauss is a famous mathematician. Okay, so it says this method has two main parts. The first part involves eliminating variables from the equation in the system. The second part involves solving for the variables one at a time. All right, so as you can see here, we have another a system of three equations with three variables, x, y, and z. And this one starts out a little bit different because if you can see here, in step one, they are using elimination right away. So it says here, use the first equation to eliminate x in the second equation. So they're doing elimination basically between the first two equations. Okay. And then they are left with just y and z, okay, in like a final equation here. All right. Then step two, you still want to use the first equation, but now you want to eliminate x in the third equation. So now you're using the first and third equations, and you have to eliminate the same variable. So they're eliminating x again. And if you can see here, they're left with y and z again, okay? So now you have two equations that are left with just two variables, y and z. So what you can do in step three is take those two and plug them in, and you can choose what you would prefer, but you can solve for either y or z by using elimination, okay? So that's what they did here. And then once you've solved, again, it's just kind of like plug and chug, and we already have the z. So then plug that in to find y, and plug z and y in to find x. And then you will be done, and you'll write your answer as an ordered triple again, like they did here. So 1, 4, 2. Okay. So I know that's kind of quick, but again, this example is in your book, so you can refer back to it at any time. And I am going to go ahead and work with you guys through this example A here. Okay. So example A. All right. So it doesn't really matter which variable you choose to eliminate as long as you eliminate the same one in both steps 1 and 2. So let's go ahead and step 1. So we have, actually, I'm going to choose to eliminate z because those are going to eliminate pretty easily. So here I'm going to rewrite my first equation and second equation. Okay, so the reason I chose z is because right away I can see with a negative z and a positive z that those are going to get eliminated. Okay, so now I'm just going to go ahead and add. So 2x plus x is 3x. Y plus 2y is 3y. Whoops. And then the z's cancel. Negative 2 plus 11 is 9. Okay. And I'm going to leave that for now, but remember in step 1, we did the first and second equation. Okay. Now in step 2, and I'm going to write that right here, we need to do, let me erase this, we need to do the first and third equation. And I need to eliminate the exact same variable, z. So I'm going to rewrite this, 2x plus y minus z equals negative 2. And I'm writing my third equation, negative 2x plus y plus 2z equals 15. Oh my goodness. All right. I don't know why it keeps moving on me. Okay. So, excuse me. Now, in this one, we need to cancel out z or eliminate z. It's not going to do that as easily as the first one. So you need to figure out what you can multiply your entire equation by to get it to cancel. So we have a positive 2z in the bottom equation. So on the top, in order to eliminate, I'm going to multiply this entire thing by 2, because then I'll have a negative 2z, which will cancel with my positive 2z. So let's go ahead and do that. We're distributing, and so on. So we have 4x plus 2y minus 2z equals negative 4. All right, and then we're going to rewrite this one, the second one or the bottom one, exactly the same. All right. And again, what's nice is these will cancel. Okay, give me the pen. Thank you. All right. So here we go. Now we're going to be left with 4x. And again, you're adding these. So 4x plus a negative 2x is 2x. 2y plus y is 3y. And then the z's are canceled. And negative 4 plus 15 is 11. Cool. So now what we want to do is take these that we came up with and put them together and do elimination again. So third step, third time we're going to do elimination. So now we're doing 3x plus 3y equals 9, and 2x plus 3y equals 11. And it doesn't matter which variable we eliminate here, x or y. It looks like the easier option here would be to multiply everything by a negative 1 so that the y's will cancel. So I'll have negative 3x minus 3y equals negative 9. And again, I just distribute that. Okay. And then I'm going to rewrite the second one, which is 2x plus 3y equals 11. And this one is going to work out where the y's do cancel. And then we're going to add just like we did before. So negative 3x plus 2x is a negative x. The y is canceled. And negative 9 plus 11 is going to be a positive 2. And then if I divide both sides by a negative 1, we get x equals a negative 2. Okay, so that is my first part of the solution. Now, obviously, you guys know we have to plug back in to find y and z. Okay, so it doesn't matter. Either of my highlighted ones I could plug back into. So I'm just going to pick this first one here, and I'm plugging x back in. So 3 times negative 2 plus 3y equals 9. This is going to give me a negative 6. I'm going to add the 6 over, so I get 3y equals 15. And so y equals 5. And that's going to be my next part of my solution. And then the last part, we have our x, we have our y. So let's plug into one of the original equations to solve for z. And I'm just going to pick this first one. So 2x plus y. So 2x we know is negative 2 plus y we know is 5, minus z equals -2. So 2 times -2 is -4 plus 5. Okay, -4 plus 5 is 1. And then I'd subtract the 1 over, so -z equals -3. And if I divide both sides by a negative, I get z equals 3. Alrighty, so then I have my x, y, and z, and my final answer would be, as an ordered triple, -2, 5, 3. Voila. Okay, so that is elimination. Notice we literally did one step of elimination with the first and second equations, eliminating variable z. Step 2 was another set of elimination, doing equations 1 and 3, eliminating variable z. And then once z was eliminated in both, we could do another set of elimination, and you could have chosen to eliminate x or y. We chose to eliminate y, so we got x equals -2. Then we plugged back in to get y equals 5 and z equals 3. Cool. So that's pretty much it. Both of these methods, substitution and elimination, are a little longer, but we will show you a way to do it on the calculator tomorrow in class. So have a good one and see you guys later. Bye-bye.